Welcome to the video lecture for Chapter 1. This is Intro to Statistics, and this is STA 2023. My name is Jorge Young. So the section that we're going to cover here in this particular video is Section 1-1, so Statistical and Critical Thinking. Talked about this in the previous lecture a little bit, so we're going to kind of expand on it in this particular lecture. So the key concept is the process involved in conducting a statistical study consists of you prepare, analyze, and you conclude with the data that you have. Now, statistical thinking involves critical thinking and the ability to make sense of the results. And those are some of the things that we're going to learn in this class. Statistical thinking demands so much more than the ability to simply execute complicated calculations. And that's a very important point. I don't emphasize the computational aspect of the formulas that we're going to use. I am more interested in the first sentence, the critical thinking and the ability to make sense of the results. I believe that even if you can find some descriptive stats about a particular data set, I rather you understand what it means in the context of the information that you have. And so, although we will learn the computational aspects of some of the formulas, that's not the emphasis that I do in this course. So data is just simply a collection of observations such as measurements, genders, or survey responses. Now, statistics is simply the science of planning studies and experiments, obtaining data, organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusions based on them. Now, one of the things that we talk a lot about in statistics are its population, sample, and other terms that you're going to have to know what they are when you hear them. So the first thing is a population. And a population is simply a complete collection of all measurements or data that are being considered. Typically, a population is a complete collection of data that we would like to make inferences about. And so we will talk about the two parts or the two aspects of statistics, which is descriptive and inferential statistics. Now, the next thing, what's the difference between a census and a sample? Census is a collection of every data from every member of a population, and a sample is simply a sub-collection of members selected from a population. And so an example would be all of the students of PHSC would be, if we were to sample every single student, that would be a census. A sample would be simply the students that are in this section of statistics. That would be a sample. So here's an example of residential carbon monoxide detector. So in the journal article, residential carbon monoxide detector failure rate in the United States, it's stated that about 38 million carbon monoxide detectors are installed in the United States. Now, there was a sample of 30 of them that were randomly selected and tested. It was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. So, in this case, the population, all 38 million carbon monoxide detectors installed in the United States. The sample are the 30 detectors that were selected and tested. So the objective is to use the sample data as a basis for drawing conclusions about the population of all carbon monoxide detectors. And methods of statistics are helpful in drawing such conclusions. Now, some of the things that students always say is they always argue about the sample size. And as long as we collect the data in a legitimate way, we don't need to sample 25,000 or 40,000 or so on and so on. So the next thing we're going to talk about, make sure I didn't skip any. So next thing we're going to talk about is statistical and critical thinking. So you got prepare, analyze, and conclude. So the first thing is prepare. And prepare, you got three sections: context, source of data, and the sampling method. So the context is what did the data represent? What is the goal of the study? The source of the data are the data from a source with special interest. So there's pressure to obtain results that are favorable to the source. We talked about this in the ethics. The sampling method, where the data collected in a way that is unbiased, or the data collected in a way that is biased. So we have to be careful with that. So that's the preparation of the data, and a lot of times that involves just simply cleaning it up. So analyze, graph the data, and this is really important. Before we even start doing any test, we want to graph the data. We want to visualize it. We want to see what it looks like organized in some type of way. The next thing is explore the data. So are there any outliers, numbers that vary from away from almost all the other data points? And so we'll talk about this in the course again. What important statistics summarize the data and descriptive stats? It's basically that you're just describing the data set that you have. How are the data distributed? So this is another thing that we'll learn later on in the course. Is there a pattern? Is there a certain type of distribution to the data that we have? Are there any missing data? And a lot of times we are missing data, and so we have to sort of clean that up a little bit. And then many selected subjects refuse to respond. The next thing is apply statistical methods. And this is where we use technology to obtain the result. And I want to emphasize that you don't really need a calculator in this course. We're going to be using Excel, and it's just going to make life a little easier. And then the last thing, conclude the significance. Do the results have statistical significance, or do they have practical significance? So here's an example: pleasure boats and manatee fatalities from boat encounters. So pleasure boats in tens of thousands and manatee fatalities. So the context is the table includes the number of registered pleasure boats in Florida in tens of thousands, and the number of manatee fatalities from encounters with boats in Florida for each of several recent years. So the format of the table suggests the following goal. We're going to determine whether there is a relationship between the number of boats and the number of manatee deaths resulting from the boats. So the source of the data in the table are from the Florida Department of Highway Safety and Motor Vehicles and the Florida Marine Research Institute. So these sources appear to be reputable. And so I know sometimes people have issues with governmental agencies, but you can trust them, right? I mean, they're not going to put out data that is flawed. Unlike some, let's say, a network, MSNBC or Fox News or some newspaper. And so if it comes from a popular source, right, like a network, I would be a little bit suspicious. But if it comes from a governmental agency, you can pretty much trust the data that you receive. The next thing is a sampling method. The data were obtained from official government records known to be reliable, and the sampling method appears to be sound. So the next thing we're going to talk about is voluntary response sample. So voluntary response sample, a self-selected sample, is one in which the respondents themselves decide whether or not to be included. So the following types of poll are common examples of voluntary response samples. Now, by their very nature, all of these are seriously flawed because you can't make a conclusion about the population on the basis of samples with a strong possibility of bias. And such polls would be an internet poll, which online people can decide whether or not to respond. Mail-in polls, which people can decide whether or not to reply, and telephone call-ins, which newspaper, radio, television announcements ask that you voluntarily call a special number to register your opinion. And the issue with these is that they're not controlled. There's no scientific method, especially internet polls. Those are terrible. And they're terrible because if I see something, I can vote as many times as I want to. And so you don't know where you're getting these responses from. So they're not reliable at all, despite what you might read or see on TV or read in the newspaper. So here's an example. Nightline asked viewers to call with their opinion about whether the UN headquarters should remain in the United States. Now, viewers then decided themselves whether to call with their opinions. Now, 67% of 186,000 respondents said that the UN should be moved out of the United States. Now, in a separate independent survey, 500 respondents were randomly selected and surveyed, and 38% of this group wanted the UN to move out of the United States. Now, that's a big difference between 67% and 38%. Some people might say, well, 67% of 186,000 is way more than 38% of 500. However, we know the two polls produced dramatically different results. So even though the Nightline poll involved 186,000 volunteer respondents, the much smaller poll of 500 randomly selected respondents is more likely to provide better results because of the far superior sampling method. So I don't need 186,000 respondents. If I can get 500 randomly selected respondents in a legitimate sampling method, then I'd much rather have that than 186,000 votes, if you will, that I don't know where they came from. The next thing is analyze. So after completing our preparation by considering the context, the source, and sampling method, we begin to analyze the data. So we're going to graph and explore. And this is also known as exploratory data analysis. So this is an analysis that should begin with the appropriate graphs and explorations of the data. And then we're going to apply statistical methods. A good statistical analysis does not require strong computational skills. Now, a good statistical analysis does require using common sense and paying careful attention to sound statistical methods. The next thing is conclude. So the final step in our process involves conclusions, and we should develop an ability to distinguish between statistical significance and practical significance. So statistical significance is achieved in the study if the likelihood of an event occurring by chance is 5% or less. So getting 98 girls and 100 random birth is statistically significant because such an extreme outcome is not likely to result from random chance. Now, getting 52 girls and 100 birth is not statistically significant because that event can occur easily with random chance. The next thing is practical significance. Is it possible that some treatment or finding is effective? But common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. So here's an example of the difference between statistical significance and practical significance. So ProCare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. Now, in the absence of any evidence of its effectiveness, the product was banned by the FDA as a gross deception of the consumer. So suppose that the product was tested with 10,000 couples who wanted to have baby girls. Now, the result consisted of 5,200 baby girls born in the 10,000 births. So this result is statistically significant because the likelihood of it happening due to chance is only about 0.003%. So the chance doesn't seem like a feasible explanation. Now, the 52% rate of girls is statistically significant, but it lacks practical significance because 52% is only slightly above 50%. Now, couples will not want to spend the time and money to increase the likelihood of a girl from 50 to 52%. Now, no, in reality, the likelihood of a baby being a girl is about 48.8% and not 50%. So, analyzing data, potential pitfalls, misleading conclusions. When forming a conclusion based on statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology. When we analyze, when we write the conclusion, we have to write it for the reader. Sample data reported instead of measured. When collecting data from people, it's better to take measurements yourself instead of asking subjects to report results. And then loaded questions. If survey results are not worded carefully, then the results of the study can be misleading. Order of the questions. Sometimes survey questions are unintentionally loaded by the order of the items being considered. Non-response. A non-response occurs when someone either refuses to respond or is unavailable. Percentages. Now, some studies cite misleading percentages. Note that 100% of some quantity is all of it, but if there are references made to percentages that exceed 100%, such references are often not justified. And that's the end of section 1.1. Thank you.